So if your initial thought is, hey, this looks like a whole bunch of random scrap metal, well, you're not wrong. So this is what I came up with when I first started building bikes. I want to talk about how it worked, and of course all the stuff that didn't work so well. But first, I'm immediately going to go off on a tangent about design goals. Because whenever something is designed, it has to be designed for a purpose. That's quite literally in the definition of the word. So whenever you make a judgment about something, it helps to keep that in mind. And bikes are a relevant example. Imagine talking about how unaerodynamic your mountain bike is. That's pretty silly, right? Because aerodynamics are a design goal for road bikes, but not necessarily mountain bikes. So it's not fair to judge one based off of the other. You know, it's two different goals, apples and oranges, you know, that sort of thing. So with that in mind, this frame jig was an absolute success and it worked great. But now it sucks. So I'm currently working through designing a new one. So let me explain. When I started building bikes, my goal was to build one for myself, maybe one for my wife, and, you know, call it a fun project and then move on to something else. And with that in mind, buying a commercially available jig was definitely out of the question. You know, I didn't want to spend that much money, you know, just to build 2 or 3 bikes. I have a good bit of welding and fabrication experience, you know, building all sorts of random things, and, you know, I have a good background in that. And I also have a good basic set of metalworking tools. And so my goal was to make a few bikes as cheaply as possible with the materials that I already had on hand and the skills that I already had. And so that's why I say this thing was a success. You know, all the goals were met and I was able to build 3 really good bikes from it. But now my goals are changing, and so that's why this thing sucks. You know, it no longer meets all the goals that I have. But let me show you how this thing worked. So first off, I've already repurposed the main base, or I guess spine we'll call it. It's basically just these square tubes right here. These are some of the leftover bits, but it's just 2-inch square by 3/16 wall thickness tubing. I used 2 lengths of it, about maybe 6 feet long, something like that, and I ended up welding them, 2 of them side by side together, just doing little stitch welds. That way they would, you know, be even more rigid and keep the stability and give me a wider surface to work off of. I mounted that to a Harbor Freight engine stand that I already had. And that way I could scoot it around the shop, but also I could angle it if I wanted to. And so from that, I had a nice long flat surface that I could rely on, you know, 2 surfaces actually, and I'll get to that in a minute. And so then all I had to do was define the relationship between bottom bracket and head tube and rear axle. You know, that's the basics of building a bike. You define those 3 things, you've defined the majority of the bike. And so working off of that base, for the head tube I made this monstrosity here, and I ended up using this 1-inch threaded rod, and I had a pretty happy little accident when I figured out that these nuts right here actually fit inside the head tube basically perfectly. You know, there's a little chamfer on the inside of the head tube and there's a chamfer on these nuts, and they just so happen to fit perfectly where I didn't have to, you know, turn a cone or anything like that. Now, very important note, these are what are known as heavy hex nuts. So regular grade 5 or whatever from the hardware store is not the same as these. I had these lying around as scrap or extra from my day job, and they're used for structural steel connections. What makes them special is this larger mating surface, and basically it's just it's the inside diameter is 1 inch, but the outside and everything else is larger than a regular grade 5 hardware. This allows them to be used without a washer in some cases, but that's going off on a different subject. But for this, it fits perfectly inside that head tube. Okay, just a happy little accident, so I ran with it. And so this threaded rod, I used that so I could hold the head tube at the right height that I wanted, and I could adjust it just by turning the nuts up and down. And then the whole thing, I made pivot so I could set the head angle. And from that, it just mounted onto the main spine. I clamped it all in place, locked it down. And then the rest of the adjustment I used with this guy to hold the bottom bracket shell. This is just is it 1.5 inches? I think it's 1.5 inches, square aluminum, just regular bar stock, that I turned this part down so it would fit the bottom bracket shell nicely. Now I will say, before this, right when I built the first bike, I didn't have a lathe, and then I didn't have a forge-out chuck later on until recently. But I actually just squared one of the ends as perfectly as I could. Basically actually it's still right there. But I basically just stuck it on there like that, which, again, if you get it, square enough, it will work. It's obviously not ideal by any stretch of the imagination, but hey, that's how I did the first bike. But then, having it turned down allows the bottom bracket shell to just slip right on there and be held, much better, much better. So, but anyway, once I had this guy, and this was a surface to reference off the back of the spine, I put it on there, and then I could just translate, slide it back along the x-axis in this case to get the measurements right. So I had this guy to set the angle and the height of the head tube, and then this guy, or in this case the stack, and this guy I was using to set the reach. And so, but to actually set those two things was the tricky part. I pretty much just locked this in place and then moved this guy until it was in the right spot. And it did take some kind of guess and check and some really weird measuring, just because since the head tube translates on this angle, it's also translating on a little bit on the x-axis. It's moving at that angle. So one of the things I ended up doing was I actually made, just taking some regular old cardboard. That's the old trick I've done a bunch, is I took cardboard, I knew my reach and stack measurements that I wanted, and so I drew it out, using nice squares and measuring it, getting it perfect. And I cut out that triangle, just a right triangle, and then fitting it up to the jig. That way I had each point of the triangles, one was at the bottom bracket shell, one was at the top of the head tube, and I made that level and square, and I knew everything was in the right spot. And also measuring that hypotenuse is another good way to kind of do a quick little sanity check. But once those two things, once I was happy with those, I'd go ahead and put the down tube in first. That way, once the down tube is in, it locks those two together, and I wouldn't have to worry about, like this threaded rod, it flexed quite a bit. Well, I say quite a bit, in terms of how precise you want to be. But basically, once I got that down tube in there carefully, tacked or welded in place, I didn't have to worry about them moving. And from there, for the seat tube, I ended up basically just relying on the miter. Getting the miter as perfect as I can on the down tube, or on the bottom bracket first, and then cutting the extra bit to fit it on the down tube to get my seat tube angle. And this whole process was just based off of some pretty basic welding and fabrication stuff. Just, knowing where to tack it in the right spots and adjusting and nudging it true, measuring it, making sure that it's square, all that stuff. It's kind of, the more time and attention you put into it, the better the outcome. And that's one of the things that's, why I'm building a better system is this took forever. It just took so long to make sure everything was right. And then in the case of like the Mark II bike, or Mark 1 and 2, there were still some alignment issues and stuff like that. Another wonderful thing, I need to grab it. One super duper important thing was this guy right here. This is one of these digital angle cubes. Important note, this is a Klein model. It is 935 DAG, if you guys care. But this one, what was different about it is it has V grooves here along the magnetic surfaces. So for all the tubes, it would stick on there nicely. Some of the other angle cubes just have flat surfaces, and so you can't really, clock it in phase with the tube. I think this thing is made for, I think electricians use this one because it's meant for like conduit and stuff like that. But this guy helped throughout the entire process because it also has a function where you can zero it. So when my base was not perfectly level, I'd zero it on there, and then I could put it on the head tube or whatever and, check my angle. And these guys are actually surprisingly accurate. It's definitely get one of these if you don't already, because they're very useful. But moving back from that was the rear axle. So I made this plate right here with a piece of angle iron on the side of it. And this was so I could clamp it to the side of my main support. And so that was one of the reasons I used these tubes, is I had a flat surface on the side, and then I had a 90-degree surface that I could also rely on. That also allowed me to set the center line of everything. I could reference off of that front surface, whatever, I think it ended up being something like 70 millimeters or something like that, I don't remember, but that way I could get, the center line of the bike nice and true. But I had a V-block, I had a bigger one, I don't know where it went, but basically just like this, small piece of angle iron that held my dummy axle in place. So I would set the angle of the plate to give myself, the bottom bracket height that I wanted, and then this guy could just scooch it back and forth to get my chainstay length. And obviously, get it all squared up and everything like that. I will say the biggest issue, with these bikes in general, is the tolerance for your rear axle is really tight. Because if you think about it, on a rear axle, you guys can do the math if you want, but on a rear axle, these are 148 millimeters, let's just say. If we're out of square by, 1 millimeter, when you multiply that by the radius of your tire, that 1 millimeter turns into, a really big distance that's out of alignment. And that was what, on my wife's bike, my bikes were, not perfectly super duper square, and I just kind of live with it. But on hers, I wanted it to be as good as possible. And so it literally took, a couple days worth of, well, I say days, but couple hours every day in the shop of just making sure the axle was perfect, tacking it in place, checking it with the tire and everything else before it was finally, dialed in. And so that's one of the reasons I'm going to spend the time and actually build a proper jig. Because it's, again, if you're just building 1 or 2 bikes or whatever, something like this could totally work. It's definitely not the best way, definitely not the right way, but it did work. It all just depends on what your goals are and how much time and money you want to spend, really. But yeah, so I would say the biggest takeaway from this video, and I kind of already mentioned, is just think about what your goals with bike building are. At this time, this was a good solution. It worked, and I made 3 totally rideable bikes from this setup. But, as I'm moving forward, I want to keep building bikes and keep tweaking and, make the process faster and more accurate and just all around better. And so that's why I've been working through designing a totally new setup. I'm going to have to share more about that later because I don't really have anything just dialed in yet for the design. But I promise I'm going to be making videos of the entire process, so stay tuned for that. So, if you are from the future and you're looking to build a frame jig, go check out that series. Don't build this thing.